Welcome to the Master Builders Solutions Sealant Chemistry and Classification Training. This is Module 1 of 3 in the series Master Builders Solutions Sealant Training. It will provide a basis of understanding as you move into Module 2, one-component polyurethane sealants, and Module 3, hybrid sealants. This training will give you the information you need to understand what is a sealant, the most popular sealant chemistries and their attributes, why certain chemistries are better suited for specific applications, how sealant performance is measured, and how sealants are classified. Let's first identify what a sealant is. Sealants used in building and construction are designed to adhere to adjacent substrates and prevent the passage of air and water by accommodating differential movement. They also improve aesthetics. Before delving into specific chemistries, it is important to distinguish sealants used in building and construction from other types of sealing material. The term sealant is sometimes used interchangeably with caulk and joint filler, but these technologies are not equivalent. Caulks fill a gap between substrates to prevent passage of air and improve aesthetics. Caulks typically do not accommodate movement cycles, especially shear movement. Acrylic and latex caulks offer the benefits of low cost, paintability, and water cleanup, but they have very limited durability. In exterior applications, acrylic and latex caulks exhibit high shrinkage, low movement capability, and may have a very short service life. There are also silicone caulks, which have good performance, but are expensive and have other limitations that we'll revisit in a later section. Because of these properties, caulks are mostly used for interior applications like molding and trim around doors and windows, or sanitary projects for silicone. Joint fillers are just that, fillers. Their primary function is to protect the joint nosing. This requires a product with some hardness. Typical chemistries for joint fillers are epoxy and polyurea, known for their fast cure speed and durability. Polysulfide is specified when joints will be routinely exposed to harsh chemicals. Joint fillers offer little flexibility and should not be used in joints that are expected to move, like exterior expansion joints. They cannot rival polyurethane or silicone sealants for such applications. They are typically used in flooring applications like saw cuts or control joints between slabs of concrete, or when joints need to withstand harsh chemicals, such in wastewater treatment plants, chemical plants, pools, and fountains. In addition to the specific sealant products presented in these training modules, Master Builders Solutions does also offer caulks and joint fillers as described above. Now that we've established the difference between caulk, joint fillers, and sealants, let's dig deeper into sealant chemistry. There are 4 major chemistries: silicone, polyurethane, and the hybrids, STPU and STPE. The former stands for silyl-terminated polyurethane, and the latter for silyl-terminated polyether. While they are all sealants, they are not equals. Like we explored with caulks and joint fillers, each chemistry has unique advantages and limitations that make sealants of that type more suited for some applications than others. The Master Builders Solutions portfolio includes polyurethane and hybrids. The portfolio does not contain a silicone, but this module will cover silicone properties for the sake of comparison. Earlier, we addressed common uses of silicone caulks, which include interior sink, bath, window, and other applications. As a sealant, silicones are used most commonly in new construction, mid- and high-rise buildings, for a variety of applications. Typical substrates are glass, polycarbonates, metal, vinyl, EIFS, concrete, and wood. Silicone sealants typically have a fast cure rate, with excellent UV resistance and movement properties, and really good adhesion to non-porous substrates, such as metal and glass. While they have acceptable adhesion to porous substrates, most silicones are known to stain them as a result of inorganic polymer bleed, often in a window frame pattern. Natural stone cladding and tiling are particularly vulnerable. Silicone sealants have a tendency for dirt pickup, and the color selection is quite limited compared to other materials. Paint typically won't adhere to the surface of most silicone sealants, further limiting aesthetics. They also don't perform well in abrasion resistance and are difficult to repair. Because other chemistries will not adhere to silicone, any repair must be done with a similar product, or the silicone must be replaced completely. Once a silicone, always a silicone, they say. Polyurethane sealants are the workhorse of construction sealants. This technology is used in new construction and restoration, residential, commercial, and industrial, in interior and exterior, above and below grade applications. One-component polyurethane sealants are moisture curing. When gunned, moisture in the air creates the chemical reaction that cures the sealant. There are also multi-component polyurethane sealants that add a chemical cure component. Besides moisture, a reaction between a resin and an activator aids in curing. Once cured, polyurethane sealants exhibit movement in the range of plus or minus 25 to 50%. They exhibit good adhesion to most construction materials. However, on some substrates, such as metal or very porous concrete, a primer might be recommended to optimize the adhesion. Polyurethane sealants withstand abrasion and impact, such as pedestrian or tire traffic in horizontal applications, and continue to perform well when exposed to the elements, which makes them a good choice for exterior applications. A major advantage of polyurethane sealants is that they can be painted, and unlike their silicone counterparts, polyurethane sealants, as a rule, do not stain adjacent materials. A limitation of this technology is that it is not formulated for structural glazing applications. Hybrid sealant products are usually specified by engineers and design professionals for specific performance characteristics. There are two types of hybrid sealants, STPU and STPE. Hybrid sealants are used in the same general applications as polyurethanes, but they offer extra performance advantages on smooth substrates such as metal, vinyl, and EIFS, as well as undercoatings. They are also frequently used on cement board siding applications because of the low modulus. As a group, hybrid sealants exhibit the application characteristics of a polyurethane with many performance attributes found in silicone. Like polyurethanes, hybrid sealants can be painted and do not stain adjacent materials. The chemical makeup of these hybrids results in a faster initial cure rate compared to polyurethanes. Movement capability is also superior. Hybrids are not formulated for structural glazing or thin metal-to-metal joints. While similar in most areas, there are some notable performance differences between STPU and STPE sealants. STPU sealants have an excellent movement capability of plus or minus 50%. Adhesion to concrete is good, but where they really outperform alternatives is in adhesion to metal, exhibiting a tenacious bond to kynar. STPE sealants have a movement capability of up to plus 100 minus 50% in certain test scenarios. This makes them a good choice for applications such as EIFS and stucco, where stress on the bond line must be minimized. Now that we've explored the major sealant chemistries, you may have noticed some overlap in their attributes and common applications. How can we compare specific sealant products to choose the right one for the job? ASTM C920 is the standard specification used in the industry to evaluate and compare sealant performance. It includes tests for flexibility, hardness, and adhesion. The results of these tests determine sealant classification. The ability of a sealant to move is very important to long-term performance. ASTM C719 provides a standard method for subjecting samples to repeated cycles of both extension and compression in a laboratory setting. This test is the source of the movement capability ratings referenced earlier in the training. The threshold of movement the sealant can withstand is described as a plus or minus percentage. The plus portion is for extension, the minus for compression. There are classes rated plus or minus 12.5, 25, 35, and 50%, where the amount of extension and compression is equal. The most flexible class is plus 100 minus 50%. A sealant cannot be rated at minus 100% because then the joint would be fully closed. While ASTM C719 is the standard, flexibility can also be evaluated through tensile strength using ASTM D412. Watch the Sealant Chemistry Matters video created by Master Builder Solutions for additional insight into sealant testing. Hardness is measured using ASTM C61 as a guide. In this test, a prepared sample of sealant is probed with a durometer and measured on a scale of 0 to 100, with 0 being the softest result. The Shore A indenter and scale are used to measure soft sealants like silicones and polyurethanes. Shore D is used to test semi-rigid joint fillers. Adhesion testing is done following ASTM C794, where sealant samples are placed in a tension testing machine. Force exerted is measured, as well as mode of failure from substrate. The higher the reported number, the greater the adhesion. While not part of ASTM C920, another protocol, ASTM C1521, measures how much the sealant can stretch and recover to its original geometry. This is commonly referred to as a field adhesion test. It contains two procedures. In the non-destructive procedure, stress is applied to the sealant to cause either adhesive failure at the bond line or cohesive failure of the sealant or substrate. In the destructive procedure, the sealant is cut to create a tail, which is then pulled. The elongation achieved before failure is recorded. Contractors and engineers should require field testing on projects to validate adhesion. Your Master Builder Solutions sales rep can provide an adhesion test reference guide. In addition to reporting results of relevant testing on technical data guides, reputable sealant manufacturers will provide ASTM C920 classifications. Let's look at the classification for Master Seal NP1 one-component polyurethane sealant, which reads Type S, Grade NS, Class 35, Use T, NT, M, A, I, and O. This means it is a single-component, non-sag sealant that can regularly expand and recover 35% of the joint width. It has been tested and deemed acceptable for use in traffic and non-traffic joints, in mortar or masonry, on aluminum or metal, and for immersion in water, as well as other types of construction applications. Sealants can also be multiple-component pourable or self-leveling, with varying degrees of movement capability, for use on a variety of substrates, including glass. These classifications can be used to quickly compare the performance attributes of sealants and determine the most suitable product for the job. This concludes the Sealant Chemistry and Classification module. You should now have a better understanding of the difference between sealants, caulks, and joint fillers, the performance attributes of silicone, polyurethane, and hybrid sealants, and the industry standards used to measure and compare specific sealants. In Module 2, we will explore the Master Builder Solutions one-component sealant portfolio. In Module 3, we will do the same for Master Builder Solutions hybrid sealants. Contact your Master Builder Solutions sales rep for additional tools and resources, like the Master Builder Solutions on-the-job app, available for your smartphone. Master Builder Solutions.